about projectile motion, what you guys need to understand is this, okay? As you're talking about projectile motion, how different is it from linear motion? Okay, linear motion, you're trying to study something moving just in one direction, and we study something moving in what? In X direction, okay? Now, when you talk about projectile motion, it's like, so you're trying to notice that the object is moving both in the X as well as what? In the Y, okay? So that's why we're going to call projectile motion as the two dimension, okay? It's motion into what? Dimensions. That's the only difference with linear motion, okay? With projectile, you begin to study an object in terms of gravity as well. How does it affect the motion? Okay. That's the basic information about projectile motion, okay? That's how different it is from linear motion. Okay. So I believe you guys already studied freeform motion. Okay. So to start with, I just want you to know how many questions I'm just asking this for this simple thing from you guys. Just know for me 3 formulas, which I believe you already know. May you help me with your formulas under linear motion? The first one is what? Help me with your formulas that we know under linear motion. No, not that one. That one is out. Okay, so you're saying acceleration is equal to v minus u over what? Over t. Okay. So we cross and multiply. What are we going to have? T times a to be 8. Then you have v minus u. So when this one comes the other side, it will be v is equal to u plus what? 8. So this is the equation that you see by linear motion, but it comes from that. Okay? So I want it in this form. V, it's actually V final. Okay. V is equal to u plus 8. Imondi, you can also give us an equation. From the 3 equations of linear motion, actually 4. I want the basic 3 one. What are the other 2? Any that you're able to recall? Any formula? Since she's not part of the lesson, okay. Comfort. What formula can you remember? Okay. Yes? So, Madam Comfort, is this speed? Okay. So the formula that you see, S is equal to, I've put D there. Okay. So it's displacement and not what? And not speed. Alright? Okay, then the other formula. Somebody else? But why were you quiet on the second part? Then I was asking. Are you sure? Then S is what? In the formula that is given us. Okay. So guys, what I want you guys to understand is, I don't want to rush you. I want you to understand. Okay. So this, all I'm asking from you guys is just know these formulas for me. They're enough for projectile motion. Okay. Just these formulas, they are enough for projectile motion. They are enough. Just know these formulas. Okay. Then you do yourself a favor. Okay. You don't have to know the other formula. Just know these formulas. That's all. Then the other thing that I want you guys to understand is now the concepts. Get the concepts. Okay. Okay. So the way I'm going to do it, I'm going to show you how they come up with the formulas. But all I want you guys to know is these formulas. Okay, they're enough. Okay. We've talked about the formulas. Okay. Let me before I get to projectile motion, I want you guys first of all to understand free form motion, because it's quite impossible for you to understand projectile motion without understanding linear and free form motion. Okay, so let's look at free form motion. So under free form motion, I'm going to talk about up and down. Okay, where you're just studying. Okay, remember linear, you're studying what? The x direction. For free form motion, you're studying what? Y only. Okay, so here you have something like this. Okay, then here you have something up and what? And down. Right? Are you guys getting what I'm saying? Okay, so let's have a question. You are down, right? Then you throw something up, straight upwards, with a velocity of with an initial velocity of 40 meters per second. Then they ask you to say, find the maximum height. Which formula do you think? Which formula can you use? Before you even give me the answer, one thing that I want you guys to understand as well is, yeah, you're down here, right? You're standing on the ground. Then you throw something with an initial velocity of 40 meters per second. Let's say a ball upwards. So, what will be the maximum height that the ball is going to reach? Going up. Mm-hmm. Might touch up your hands. Yeah, wow. Okay, that's great. That's great. Somebody already solved the question. We are still trying to analyze the question. Okay. So, what I want you guys to understand is this. Okay. When you've been given a question in physics, we have our formulas there, right? Okay. So be able to pick out the information, the data that you've been given in the question. Okay. So from this question that we've been given, I want you guys to give me what you know. What have we been given in this question? We know that our U is equal to what? Which is 40 meters per second, right? Do we know the maximum velocity? Oh, the final velocity at the maximum point. So, Imondi, when something is going up at the maximum point, what will be the speed? You don't know. Okay. Then do we know the acceleration? Do we know the acceleration? So it's going up. It's going up. So the moment acceleration is negative, it tells you that something is going to be reducing the speed, right? So when a ball is going up, it will be reducing the speed as time progresses, okay? But when it's dropping, it will be increasing. So we therefore say our A is negative 9.8. So now, what I want you guys to get is this. When you come up with the information, you have your data there. I want you to pick a formula that has all the information that the formula that will only require you to use the given information and what you want to find. Okay? Because there's no way you've not been given time, but you want to use a formula that is involving time for you to find displacement. That's wrong. Okay. It's right, but it's going to take you time because you have to find t. And that's when you get back to what? So I hope that's not what you did, Shatton, right? I hope you didn't find time. You just answered. Okay. So now, I think you are not going to give us an answer. So let me ask the others. So from the formulas that we have here, which one do you think has this information? And we are asked to find S. So which formula is comprising of these? From the third one, right? Okay. So if you're able to identify that, then you've already answered the question. So now what the guys are going to do is, without putting the information that is there, what they know is, they know that v squared, whenever something is going up, it's 0, right? Then this one, that is our initial velocity. Okay. Plus. When you're going up, the acceleration, it becomes gravity. Okay? And when you're going up, we are saying it's negative, right? So negative g. The displacement of a distance is what? The height. So we want to make this to be a subject. So it crosses the other side. It will be positive 2gh equal to u squared. If you make h a subject, you have u squared over what? Over 2g. Okay. So this is the formula that you're going to meet under free-form motion. But for me, I think it's not necessary for you to find this formula. You can just substitute and find h. That's enough. Or you just find s. They're not going to penalize you. They're not going to tell you, no, you found s instead of h. No. They're interested in the answer. Okay? But then, when you go back to projectile motion, you're going to see that when something is actually thrown up at a certain angle, right? Maybe 30. You need to understand that that velocity has got the x and the y component, right? So, in such a case, the y component is given by what? The velocity multiplied by what? Is it sine or cosine of the angle in the y direction? So it will be v sine theta, right? So I appreciate that, guys. Thank you very much. So now, if this was projectile motion, would have the formula becomes our initial velocity becomes v sine theta squared. That's why we map that formula in cada chan. V squared sine squared what? Theta over what? 2g. If we come across this formula, yeah. So where is it coming from now? The same formula, right? So it's not necessary for you to master this formula. Me, I've never mastered and I'll never master it because what? I've got a lot of things to keep. things like biology, not my physics. Just know these three formulas, that's all. Okay. Is that okay? Yeah. So I'm showing how to come up with the formulas. Okay. So now we are able to find the maximum height in such a case. I'm not interested in even finding the answer. I'm just interested in you guys getting the concepts. So now, this same question. What will be the speed that the ball is going to hit the ground with? Okay. As it goes up, then gets down. What will be the velocity as it reaches the east? Which works? Let me say the point where it was coming from. When coming down, what will be the speed? This is where it started from. It goes up. Now as it is coming down, as it reaches the exact point where it started from, what will be the speed? Which formula can we use? The answer will be the same, right? To move 40 meters per second. Don't even think of a formula. Don't think of a formula. Because the first one will require you to use time. So, I'm telling you, when we throw you up at 20 meters per second, when you go up, as you get to come down, you reach the ground with the same what? With the same speed. That's the funny part about it. Okay? So understand that. Those are the basic things about free-fall motion. Okay? We use gravity and acceleration. Where there's distance, displacement, we put height there. Okay. So these are the basic things about linear motion and free-fall motion. So now let's try to study projectile motion. How do we come up with the formulas, guys? How do we come up with the formulas? Okay. So you guys, we have got 3 cases under projectile motion. I want you to tell me the cases that we have. I'll tell you the first one. The first one is you are on the level ground. Maybe you kick the ball. The ball will move like that. Okay. You have an angle there. Okay. From the ground, then it gets down again. Which other case do we have? Okay. Okay, let's say this ball just come like, you kick it horizontally, maybe from this direction. So that it just comes down like this. Okay? That's case 2. Then the last case is what? You're at a cliff, then what happens? You're also at a cliff, but this time around it will go up. These are the questions that you should be expecting, guys. These are the only things that they're going to ask you. Is there anything else? So this one is it. The third one is the combination of what? This one and that one. We've combined them. Okay? Are we together? Are we together? Okay. So now let's try to understand what happens. I don't want to begin, doing things that are not important here. So I don't want to. Okay, let me give you the basics. Some more basics. Let me give you some more basics. Some more basics. Okay, I'll start with the first case. Okay, let's have an example. All right. Let's have an example. Okay. So you kick a ball at an angle of. They'll tell you. Sometimes they don't even. Most of the time they don't. They'll tell you you kick a ball maybe they will tell you the angle to the horizontal, maybe 40 degrees, okay? Like that. And you've kicked this ball with an initial velocity of maybe 80 meters per second, right? It's too big. 10 meters per second. Okay? I'll start with a basic question. Okay, so have we understood? You've kicked a ball that is making an angle of 40 degrees to the horizontal with an initial velocity of 10 meters per second, right? The first question they're going to ask you is, these are the possible questions. Find the maximum height. Okay. Find time taken to what? To reach a maximum height. They also ask you time of what? Of flight. They can also ask you they can also say maybe find the velocity after 2 seconds. Find the range. What is the range? Okay, how can you explain the range? It's the horizontal what? What's the range? Okay, so the distance in the x direction, horizontal distance. Then what's the relationship between time taken to reach a maximum height and the time of flight? What relationship is that? I think, is it the network? Yeah. Are you having challenges with the network? I'm recording the class, so don't worry much. Okay. So, what is the relationship between the time it is going to take to reach a maximum height? Let's say it is 2 seconds. Then what will be the time of flight? And how can you explain the time of flight? Good. Okay, so it's double. The time it is going to take from A to B will be twice the time from A to C. If here it's 2 seconds, there will be 2 seconds, meaning the total time is going to be 4. That's how it moves. Right? Okay. So, like I said, the time it takes to reach the maximum height. So, let's write our data. So, when you're talking about the maximum height, whenever you've been given a question under projectile motion, you guys, you should be able to identify the motion that you're studying. Are you studying the X or the Y? They've asked you about the maximum height. Are you studying motion in the Y or the X direction? In the Y, right? So now, what information do we know? What is the initial velocity in the Y? It is 0 in the initial velocity is 0. Are you sure? But if it's 0, how then is it possible that it's good? Okay. So what is our V in this case? I don't know for the initial velocity because, okay, I'll use V naught. Which one do you use? Do you use U or V naught? Because you students, you get okay. 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 Better. So what is our initial velocity in the y direction? Okay. Then, so in this case, what is our v naught? So it's 10 sine what? 10 sine 40. Okay. I don't want you to punch it already. Okay. So what is our formula? What is our initial velocity in the y? Then what else do we know about the maximum height? What will be the final velocity at the maximum height? What else do we know? Do we know the acceleration? Whenever you're studying motion in the y direction, know the acceleration, which is g. It is going up, we're going up. I want you to I don't want people confuse you where they tell you, no, you can consider it to be negative. You can also consider it to be positive depending on what you consider. I don't want that. Just know that going up, it's negative. Negative 9.8, right? Yeah. So now, we'll go back to our formulas from the three formulas. The maximum height. Are you asking the maximum velocity? The velocity at the maximum point. Yeah, when something is going up, madam. When something is going up, at the maximum height, it can't go up anymore because like there's no, it has stopped moving, so it can't continue going up. So that's why I'm saying that at the maximum point, something has to stop moving. Okay? Then due to gravity, it will start moving down again. Okay. So at the maximum point there, it doesn't move. It was like, it doesn't just like go like that's no. It will go like, yeah. So it will be like yeah. Just like maybe you see maybe I can call it instantaneous lists. Okay. To be just for an instant, it will like stop moving, then it will begin coming down. Okay. So now, from the formulas that we have this one, then we have this one. I only asked for this favor, you guys. Only know these formulas for me, then you are home and dry. So now, which formula has got all this information? Then what are we finding? We're finding S of the height. Which formula has got this information? So whenever you are not given time, think of the last formula, okay? Is that okay? I don't want to use the approach of using formulas where we say, no, maximum height, 2 0 b, v squared sine squared theta. Well and good if you know. Well and good. Okay? Well and good if you know. But sometimes you may make a mistake. Understand where it's coming from. So you go for the v squared. V squared is equal to u squared plus 2as. Okay. So what do we know about phone of pesa s? Okay. I don't want to come up with a formula. I don't have enough time in an exam. If I try to solve up, final velocity is 0. I'll put there. Initial, it's v sine theta, which is 10 sine 40. The answer that I'm going to find is supposed to be squared plus gravity, acceleration is negative 9.8. And I'm finding S. Okay. So 10 sine 40, what are we getting, guys? 10 sine 40, what are we getting? I don't have a calculator. I don't know where I've put my calculator. What are you finding? 6? I'm trying to get my calculator. Okay, found it. Monday. You're saying it's what? Sorry, I wasn't getting you. I was just speaking out from my lamb. You've squared it already? You squared it? But there's a square here. So if it crosses the other side, it will be negative what? Okay. Then the other side there we have 2 times negative 9.8. Okay, so divide by negative 19.96. So our height is 2.11 meters. Okay. Somebody may argue, sir. Okay. We'll still consider them. So you choose which one is easier for you. Okay. Of course, somebody else is going to use this one. Try to substitute. We have 10 squared sine squared 40. I'll do this. Sine 40 squared over 2 times 9.8. What are you getting? So you have 100 multiplied by sine 40 squared divided by 2 times 9.8. Same answer. Okay. So which one is easier? This one, as this one is requiring you to master a formula that you're not familiar with. But the other one is requiring you to use a formula that you cannot forget. If you're also familiar with this one, use this one. But I would recommend to use that one there. Okay. So most of the tutors and other people want to make you know this formula. They will tell you, no, this is the formula. They will show you how to derive it and ask you to what this is where it comes from. No need of deriving the formula, just use that. Okay. We've answered the first question. The maximum height is what? 2.11 meters. Time taken to reach the maximum height. Think of a formula now that is as time. Yeah. Think of a formula that has time. There are 2 formulas there, right? Now, the moment where you say you want to find time, the moment you just go for the one asking you want to find time and you go for the second equation, just know that you are required to do what? To use the quadratic formula, and you don't want to waste time. You don't want to waste time. Time is very precious. Okay? What do? You go for the first one. The reason why I'm saying you go for the first one, the first one won't require you to use what? Your height. Okay? Because if you use the height, if your answer is wrong, even that your time is going to be wrong. Okay? But if you use the first formula there, whether your height is wrong, you may lose the marks on the first part, but for time you get it right. Are you getting me? And the same applies. If the first question was asking you to find time, then you are trying to find the height. Don't use this one again to find. Use the one that is not using the previous answer. Unless if there is no other formula. But as long as there is another formula that cannot use the answer that you had found, use that formula. Okay, so at the maximum height, our final velocity in the y direction will be what? Be 0. Okay. Initial. What will be the initial in the y direction? We said. That's the only thing that I want you guys to be. You've seen what you started saying in Mondeka. What's the initial velocity in the y direction? Yeah. Man, you are just saying 10 meters per second. You end there. Because if you begin saying that when you are talking about linear, then you are lost again. Okay. Make sure that's the only difference projector. We need the angle to be there. 10 sine 40. Not just 10. The moment you say 10, you're wrong. The answer will be very different. So I hope that is clear. So the initial velocity will be 10 sine 40 plus gravity going up, negative 9.8. We are trying to find time. This one will come the other side to be negative 10 sine 40. You are dividing by negative 9.8. Already becomes positive. So 10 sine 40 divided by 9.8. The time is what? Chap one off. That's the way to go. 656. Okay, me I'm ending there. Okay. According to the rules, actually it's supposed to be. According to the rules, it's supposed to be 656. Okay. It's not advisable to round off the answer to. It's not advisable to add the 1 when it's 5 itself. That's what I'm told. Yeah. Especially in chemistry, it's not advisable to do that. Okay, that's perfect. Okay, and I want to tell you again. I'm giving you 2 options. Yeah, my phone wants to go off. Okay. Okay. I'm giving you another option. Again, for this one. Okay, before you ask, I'm not erasing. So the other formula that you're going to find is V is equal to U plus 8, right? You want to make it the subject. Okay. Leave it that side. Let this one come the other side. Final is going to be 0. Initial is V sine what? Theta. V naught sine theta. Your acceleration is gravity and it's negative when going up. So negative G. T. It comes the other side, it becomes GT. Okay. You divide by G. The time becomes V sine theta over what? Over G. This is a formula that I'm going to tell you. Master this formula. We use this formula to find time. Try to substitute there to see what you're going to get. Already you're able to see that this part is this part, right? 10 sine 40 there divided by 9.8. Is that different? Not different. So you know this formula or you master that one. It's fine. So and what you're going to find is you may even put a v squared there. Because you are confusing it with the height, so it's better you use these formulas. Okay. You can ask your question. Ask your question. Have I explained that? Okay. Okay. Yeah, so what I was saying is you need to understand when you're given a question, understand, is it asking me about, because projectile is two-dimension thing, okay? Which am I asked about the y or the x direction? Okay, that's what you need to understand there. Okay, so we've answered our time. Okay, are we together, guys? I think it's making sense here. Okay, that's happy. Yes, yes, sir. Oh, this one? Yeah, it's 2as. These are the linear motion. These are the formulas under linear motion, actually. I believe you know them. Okay. How about the time of flight? You mount the guide us in 2 seconds. We move. The double maximum height. Okay, thank you. Think about what you said. Double maximum height. Okay, I've gotten what she has said. Matilda, okay, you can just, yeah, I've gotten your points. Now, you, Imonde, just repeat what you said. How are we going to find the time of flight? Repeat yourself. Okay, I think there's now that kind of an understanding. You omitted the first part. Initially, you had said that you double the maximum height, so that's why there was that confusion. Okay. So the time it's taking to move from this point to B is 0.656. So according to what we know, it's the time it's going to take it in there to get down. So that's why we are saying it's double this time. Okay. If you go to the time of flight, the formula that will give you, of course, for the time to reach a maximum height, will give you v sine theta over what? Over g. So when they take you to time of flight, they'll just say, I've been telling you, I've been indicating time of flight. Okay, it's 2v sine theta. Just, it's a simple thing. They're just doubling it. Okay. All are the basic things, guys. Very important. All right. Find the velocity after 2 seconds. Already you know that the time of flight is actually less than 2 seconds. Okay? Wow. How are we going to answer that question? Find the velocity after 2 seconds. Yes. Good. Yeah. The first formula, right? So we have V is equal to U plus 8. So the final we don't know, right? we don't. It gets me clear on that point. We don't know. It only becomes zero in its what? But do we know what is going to be the maximum height? The initial velocity in the y? Gravity? Negative. Try to do my calculations. What are you getting? Your calculator is working properly, you guys. Okay. So what does it mean when it's negative? Who can explain? Yes, we can get you some. It's still negative. That explanation. Are you sure? No, like it has started with a positive velocity. So initially, I've calculated the time of flight deliberately. So you guys, if you double this time, what are you getting as the time of flight? So 2 seconds is after, right? So it's going to be the seconds. It's going to be 2 seconds after the ball as what? As is already going down, right? Okay. Are you getting me? So meaning that the possibility is this: if this person was standing on the cliff, at that point, the time is going to be 1.3. Now, 2 seconds, meaning that it will be going down. So it tells you that it is going to be moving at that speed, but in the opposite direction as you had thrown it. When it's negative, it tells you that it is going to be in the opposite direction. Since you are throwing it up, then it's going down. Okay? That's what it means. When you find the answer to be positive, it tells you that because this part is actually reducing what? Is reducing the speed. Yeah. I hope that makes sense. Okay, I'll do this deliberate again. Let's say the question was asking you to find the velocity after 1.3 seconds. Let's try to do that. So our V, that's 40, or that's 10 sine 40 minus 9.8 times 1.3 seconds. Let's try to do that. Negative 6 point. Then the initial one was what? 10 sine 40. Try to punch it again. My calculators are okay. That is like, yeah. Then 10 sine 40 again minus 1.3 by 9.8. Okay, it's just that my calculators are, we are rounding off figures here, but in actual sense, these answers are supposed to be equal. Okay. I don't know if you're able to see that. What I'm trying to say. So what I'm trying to say is, the speed something is starting with here is supposed to be the speed it's going to reach on the other side, on the same end, at the same point. Okay? But why is it negative? It's because this time around it's going down. Here it was going up. Positive, the negative. But the speed is the same. Okay. One other point that we need to understand. The last question. One thing that you need to understand under projectile motion is that the x and the y directions, these two are what? They are independent. They are not dependent, or they are independent. Is that the way you spell independent? Yeah, they are independent. So, meaning that, and one thing that you need to understand that in the x direction, what do we know about the velocity? It's the same, right? Throughout what? Motion. Okay. So to see what distance is speed times time. The range is therefore going to be equal to the speed. We are talking of velocity times time. So if you have the time of light, and what will be the initial speed in the x direction? Okay, that's why they tell you that formula it's V naught. V naught what? You said sine. Okay, yeah. It's good you said cos. I got sine. That's why I asked you again. Okay. So you find your answer. Okay. It's that simple, guys. It's that simple. It's very simple answer. Very simple. Okay. Okay? I hope we are together. Should I add one more point that I think is very important? Because tomorrow I'm going to church. Let me sum it up. Okay. Have you allowed me? You're standing somewhere on a building. Then you found something like this. Okay. The time of flight that we've talked about only applies to something that is on the level ground. Meaning that if you use that formula, you're only going to find the time from A to what? To C. Okay. So now, in this case, they've given you the height here, right? I want to explain this one. Let's say the height here is 10 meters, right? There they've given you, let's say we apply the same question. Let's apply the same speed and everything else. Let's say that is 40, that is 10 meters per second. Okay. So guys, the height that we had found the height from A to B, right? Okay. So now if I ask you for the maximum height, it is going to be 10 plus what? 2.11. Meaning that you are adding up that one to what? To this one. So that you calculate the total height from the ground to a maximum point. Do you understand? That's one point that I wanted to make. Another point is on the time of flight. Another point is on the time of flight. Time of flight, we're talking about what you've calculated from, yes, which is the height you've calculated from. Like if you are using that formula, like this one, where you are saying at the maximum point, your final velocity is 0. You are only finding the height from the initial point where something is starting from the maximum point. Now, in this case, practically,
don't sleep 8 hours a day. That's a third of your life. It ain't but 24 hours in a day. You can't.
Okay. Practically, when you're talking of the height, you measure it from the ground, right? Not so. So if you say no, the maximum height is 2.11 while you're standing on the ground, while you're standing on a building, so it doesn't make sense. You need to add the height of the building as well. Okay. Then another case that they may do, these lecturers, you need to be very smart. Okay. Let's say they say maybe instead of being standing on a building, they'll tell you maybe a 1.2 meter person. So this person is 1.2 meters or 10 feet. 1.2 meters. That's the height of this person. Then he throws something like in respect to is like yeah, you understand what I mean. Huh? He throws something from this point going up. So when you do calculations, you are determining from this person's head the maximum point. Then that is a 2.11. Let's say. So for you to find the maximum height, you need to add the height of this person. That's a basic idea there. Okay. Yes. That's what I want to explain. That's what I want to explain. So when you calculate that time, meaning you've only calculated time from A to what? From A to what? A to C. Okay. Meaning that you've not answered the question. So I want you to know that in such a case, use this formula to find, if you don't want to do complicated calculations, just get the second formula, this one. The one which requires you to use the quadratic formula. Alright? You even begin substituting. Substitute the maximum height. 10 plus 2.11. That would be 12.11. The initial velocity in the x, in the y axis, it was 10 t plus half. Gravity is 9.8 t squared. Negative 9.8 there. So the value of t that you are going to find is going to give you the total time. Alright? Are you getting me? If you still don't want to go work with that, you can work with our formula as well. Find the time from A to C. Then I mentioned one point. I said the start of velocity from this point is going to be the same even there, right? Are you getting me? So meaning that at that point C, the ball will be moving with the same velocity of 10 sine what? 40. Okay. So now you are going to say, okay, I'm now studying motion going down. The height from this C going down is 10, right? 10 meters. So you say, okay, I'm going down from C. My initial velocity at C is 10 sine 40, right? Then the height, ignore the sign. Ignore the sign for now. Ignore the sign. So you have your initial velocity at C. You also have the height going down. So now, what do you want to do? You want to find the time it is going to take to reach down, right? That's your goal. Which formula can you use? Okay. I wouldn't advise you to use the second formula because it's like going to complicate your formula. Then it's better you even use it like from my first explanation. So in such a case, this one, you have to use two formulas. Okay? Use the last one. V squared is equal to U squared plus 2AS. This formula is going to help you find what? The final velocity. You have your initial, plug in there. You have your acceleration going down is positive. Your displacement going, the height is 10. So you find your final velocity. Now, after finding your final velocity, you come and get the first formula, put in the final velocity, put in the initial velocity, and find time. So at the time that you're going to find, add it with it. The time that you had found from A to C, when you find the total time of flight. Then the answer that you're going to find is equivalent to the answer that you find using this one. So you even know now my advice. My advice is you don't want to confuse yourself. So use this one direct. Better. Because these computations, sometimes when you're stressed, you may forget. You know. Are we together? Okay. So these are things. I think this is what I think was going to be hard for you guys. But otherwise, when something is like dropping like from a cliff, just dropping like this, like it's not going up. Yes. This one is simple because this one, yeah, you this same one you actually work with the same. Oh, this one. What I say? You're saying this one, the one that I'm from doing. The same formula applies. The same formula applies. The range. All you are interested in for you is to just find this velocity in the x direction, then multiply it by what? The total time now. So the total time that you're going to find now, multiply it by the initial velocity in the x, because we know that velocity is always the same in the x throughout motion. Okay. This one is not, for me, I don't even consider this one to be like an advanced projectile motion, because this is just like free-form motion. So if you know the height up so 10 meters, find the time it is going to take to drop down. How do you answer such questions, guys? These questions are not simple. Oh, they are actually easy. Okay, so yeah, they are easy. These don't come with angles. They don't. Sometimes they may give you that somebody has thrown something down. Okay. Yeah. So I think, unless if there are questions, I think I'm tired. I've talked a lot. This is like, I've talked over an hour. Yeah. I'll just hope you. Yeah. Yes. What I say? You are confusing me. To find what the time or height? No. No. Answer my question. Are you asking about the total time or the total height? But why are you mentioning 10? Or you are saying the time it is taking from to drop a 10 plus the time it's taking from A to C? No. Okay, I get your point. No. Okay. I get your question now. So what is important is when you are using this equation is helping you to find the time like from A to the last point there. So in such a case, what you need to do is you need to put what? Put in the total height from B like to the ground. Now in this case where you're just trying to find from C going down, you use the height 10. I think that's a simplest explanation. Yeah. No. Madam. I know they would never ask you time from sea to the ground. I was just explaining, like, if they've asked you to find the total time from A to the ground. So this is the way you need to analyze the question. Analyze the question that, okay, apa I line the so na so, then from there I line the so na so. Yeah. Oh, it doesn't have an angle. No. As long as it doesn't, like without an angle, then it can't go up. Then obviously, without an angle, it can't make this kind of a projectile. Unless this one that I've drawn down. For this one, where there's no angle, where it is just dropping down. It's just free form motion. Sharp. Don't even have to stress. Could you be back my sine and the cosine? It's just to get what you're given. But except most of the time what they do is they only give you a speed in the x direction. Okay. What I'm saying is this. Okay, let me give you an example. You guys are asking a lot of questions. Okay, yeah. 40 meters per second. Exam. It's L. Okay. Yeah. You have that ball there, okay? It is somebody at the Pamonpa building, then like just the ball is moving with that speed in the x direction. So they'll ask you simple questions like the range, like Imondo was saying, like how far is it going to fall from the building? Emma questions you ask about the range. They can ask you the time it's going to take to reach the ground. They can also ask you to determine If I give you the range, they can ask you to find the height. But if I give you the height, they can ask you to find the range. So now, Matilda, what's your question? So whenever something is moving from up, like in such a case, like they have shown that one there, does it have any velocity in the y direction initially? It doesn't. So now, so in fact, they can also ask you to find the velocity as it strikes the ground. So you're asking about the time, determining the time. That's your question, Ka? You determine the time. So the question that we use is this one. Do you know the final velocity? You don't know. This one is the opposite. It's going down. You can't say no. That's it. That's where students get caught. Don't master things, okay? Because when you say it's going to strike the ground with 0 meters per second, does that make sense? Something is going down, then you say it's going to strike the ground at 0 meters per second. Does it make sense? Doesn't. So in this case where it's going down, you don't know. You don't know. So which formula can you use to find, first of all, the final velocity? You use the final one. This one. You know the displacement. You know the acceleration. The initial is 0 when going down. So you're able to find your final velocity. Who can answer that question? No one can answer that question. Huh? No. No one is supporting me. In the what? I said. No, listen. I said. Somebody at the Pamuroji, like this building is cheated or something, then throws the ball from this direction in the X. It's coming with that velocity. Then it's going to be moving like that. Is there any initial velocity in the Y? Y? The X and the Y are independent, so yeah. Do you get the points? Yeah, but I'm not saying that is the question that they're going to give you. There may be a case where they say, throws it down with an initial velocity of 40 meters per second, like that. They can specify. Now, in the case where somebody... So, you need to analyze, understand the question. Is it in the X or in the Y? Try to connect. In this case, it's in the X. So, in the Y, there is no initial velocity. All right? Okay. So now, after you find your final velocity, plug in there, plug in the initial, plug in the acceleration, then you find time. Yes. Hello. You are lost, you. I'm just joking, right? You are lost. You are lost. Okay. How am I going to explain this? Okay. When you're on top. No. Wait. Let me answer you. Okay. When it is negative when something is going up, okay? When it's coming down, positive because we are like going the same direction with the pull of gravity. Now, when you are working against gravity, we consider it to be negative. Okay? So when you're going down, are you working against it or you're actually being in support of it? So now, what's your question? If I answered your question. So you guys, you can send me something for a drink if you want me to continue teaching you. Otherwise, I'll continue, whether you send or not. So if you want to continue, you want to give me the morale, send me something for data you've not paid. Okay. Yeah. So next time we meet, we'll cover thermodynamics and what? Thermodynamics and rotational motion. Okay. So I hope you enjoyed the class. See you next time. Good night. Yeah. You're welcome. Hello. Hello. I can get you. My Airtel or MTN. Okay, 7. Yeah. Okay, 097 30 25 7. Huh? Or you want to send me Titi? Yeah, you can send that same one. It's